Good day, students. This is Ma'am Hannah, and for today's lesson, I will be discussing the research methodology. But first, let us define what is research methods. In quantitative research, this involves a systematic approach to studying a phenomenon by collecting and analyzing numerical data. Of course, since this is quantitative, of course, we will be analyzing numerical data. This process is broken into several key parts to ensure that the findings are objective, measurable, and can be generalized to a larger population. And to start with, we have these table of contents. So since we've discussed about the research design already, we will proceed immediately with the research respondents, research instruments, the validity and reliability, especially of your research instruments. And lastly, I will also discuss about the statistical treatment of data. To start with, let's have here the definition of what is a research respondent. So, according to Saunders, Lewis, and Thornhill in 2019, respondents are those individuals who provide information for the purpose of a research study. Of course, they are the primary source of information, especially when we are doing research, and their responses are systematically collected and analyzed to test hypotheses and draw conclusions. Say, for example, your study is all about the relationship of the study habits and academic performance of whom? Of course, you will have your research respondents. Say, for example, the grade 11 students of Maryknoll College of Panama. So that is your research respondents. Next is we have terms to remember when we talk about research respondents. First is the population. These is composed of the persons, or these are composed of the persons or objects that possess some common characteristics that are of interest to the research. As I said a while ago, study habits and academic performance of grade 11 students. So they possess common characteristics in which they are all grade 11 students. And of course, you would like to study their study habits and their academic performance if there is a significant relationship among those variables. And your target population, this is the ideal population. And of course, we also have this accessible population or available. So, say for example, you aim to study the study habits and academic performance of all grade 11 students in the Philippines. So, that is your ideal target population. But because of maybe the time constraints, financial capacity, and of course, um, grade 11 students in the entire Philippines is too large. So therefore, you would have your accessible population, which is you choose grade 11 students of Maryknoll. So that is the available that you have visible. Next is the terms to remember when we talk about research respondents. We have this what we call parameter. So this is the numeric characteristic of a population. And the opposite of this is the statistic, in which this is a numeric characteristic of a sample. In parameter, we do have what we call the sample or the subset of the entire population. And in the statistics, we also have what we call the element or a single member of the sample. So next is what are the factors to consider in determining the sample size? First is we need to ensure that there is a homogeneity of the population. So as I said a while ago, say for example, the respondents should have similar characteristics, right? Next is the degree of precision desired by the researcher. Here, in quantitative research, the larger the population, the better is the result. So it's better if you have larger respondents or larger scope of respondents so that you will have this more precise interpretation of your results. Next is what is the type of sampling procedure that you were able to apply or that we were able to use. Next is the use of formulas, and we also have other considerations. So with that, we will discuss individually these terms. How do we solve our sample size. So we will use this what we call Sloven's formula. I will first use the pen so that it's easier for you to see what I'm trying to say. Here, in the Sloven's formula, n here, or the small n, represents the sample size. Say, for example, in grade 11, there's a total of 489, assuming there are 489 sample of number of, what do you call that? Number of respondents. So you can't really attest that you can survey all of them. So therefore, you need a sample size. Here, n is the total of the population. In this case, that is 489. And E is the desired margin of error, in which this is constant. So this formula is what we're going to use in order to solve for the sample size. Next is we'll have some sample calculations. We will have it on the next slide. Say, for example, we have here, wait, let me erase first everything. Why can't I erase? Okay, let's move forward to the next slide. Okay, how about we have here some example. Let me first erase everything that I've written on the screen. There. So once again, we have here the total population of 240 students, and we are trying to solve for the sample size. So in this case, we will just substitute n, or the big letter n, as 240, and then 1 is given, and then the next one is 240, which is still the n. This 0.04, this is our margin of error. And then we need to square it based on the formula. 0.04 squared, that is 0.0016. And then please observe the PEMDAS rule, or multiply first what's inside the parenthesis, exponent, and then PEMDAS, multiplication, division, addition, and subtraction. In this case, we will just copy 240, and then after multiplying 240 and 0.0016, we will get 0.0384. And in that case, if we try to add it with 1, we will get 1.384. And since it's already simplified, we are to divide 240 by 1.384. And in this case, our sample respondents, or n, from the 240 entire population, we can conclude that we can use a sample of 173 respondents. Okay, that's how we solve for the sample size. And to continue, let me erase first everything and proceed on the next slide. What if we have here another formula for calculating the sample? And this we will use the Kalmurin's formula. But again, the most common formula that we use in calculating the sample is the Sloven. So this is another formula in which, of course, SS represents here the sample size, and still the population size. V is the standard value, which is 2.58 of 1% level of probability with 0.99 reliability. And SC is the sampling error. P is the largest possible proportions. So there, we will have here some sample solving. To start with, we have here, okay, the next slide. Let me first erase everything and proceed to the next slide. As what we can see here, okay, why is it not? Wait for a while. Once again, this is a sample solving. Say, for example, we have a total population of 800 respondents. Okay, let's encircle. This is our big letter N. This 2.58 here is given. This is our standard value. And of course, still the 0.01 is given, in which this is the level of probability. Next is we're going to subtract 1 minus P, which is 0.50. And in this case, if we try to substitute everything, as you can see, this is, we follow still the PEMDAS rule. 800 times 2.58, that's 2064. 0.01 squared plus 1 minus 0.5. We have here this one. And after that, we will gonna try to add everything. 2.064 plus 0.001 times 0.5, we will get 2064.005 over 8 plus 1.665. So basically, if you have your scientific calculator, if you try to input these values in your scientific calculator, you will eventually get the final result, and that will be 214. So out of the 800 respondents that we have here, you will have a sample respondent of 214. Please excuse this one. This should be times, because based on the formula, this should be multiplication. So again, using this Calmary's formula, you will have a respondent of 214. So here, we have a summarized table for the sample respondents using the given formula. So here, Calmarin's formula, say for example, you have a sample of, you have a population of 400. Your ideal sample size is 180. This should be small letter n. And if you have, say, for example, 850 respondents, you will have 216 sample. And a while ago, we were able to solve 800, and you got 214 sample respondents. We have a summarized table. But once again, the Sloven's formula is a commonly used formula in solving for the sample size. So next is, we're gonna close this part, clear all the drawings, and proceed to the next slide. So there are also other considerations. Sample size or sizes as small as 30 are generally adequate. Here, this is widely cited rule for the rule of thumb. It often tied to the central limit theorem, which states that the distribution of sample means will be approximately normal for a sample size of 30 or more. Another assumption is that when the total population is equal or less than 100, this number may serve as the sample size. So this is accurate and generally recommended practice, especially when the population is small. Of course, researchers often conduct a census where every member of the population is included in the study. Next assumption is that acceptable sizes for different types of research. For descriptive, that will be 10% to 20% of the population may be required. For the correlational, that will be 30 respondents. Comparative will be 15 subjects per group. And for experimental, we can have 15 to 30 subjects per group. And this is actually an oversimplified guideline, which can be misleading. This is common, but a very minimum rule of thumb. So a sample size of 30 is generally considered the lower limit to detect a moderate correlation with statistical significance. So this is really not advised, because in quantitative research, the larger the sample size or the larger the population size, the better is the accuracy and precision of your result. And to continue, we have here different kinds of sampling technique. So we have what we call the probability sampling and the non-probability sampling, in which in probability, it uses fair way of getting a sample of the sample respondents of your study. In non-probability, of course, most of the time, or in non-probability sampling, the respondents are chosen by the researchers purposefully. And when we talk about probability sampling, each member of the population has a chance of being selected for the sample, in which the selection is random and unbiased. And the primary purpose of this method is to create a sample that is representative of the population. This allows researchers to make statistically sound generalizations about the entire group. And to start with, we have these types of probability sampling. First, probability sampling is the simple random sampling. I think in your general mathematics in grade 11, you were able to talk about these types of probability sampling. So this is not new to you. So in simple random sampling, of course, every individual has an equal chance of being selected. So it means it's unrestricted. Next is what we call the stratified random sampling, in which this is divisional. Why? Because the population is divided into subgroups or what we call strata. And a random sample is taken from each stratum. Say, for example, your respondents are grade 11 students and you would like to group them according to their electives, say, for example. So, therefore, from the chosen electives, from the given electives, you will going to have proportional respondents for each of the electives. Next is cluster sampling. So in cluster sampling, this is commonly known as aggregational, in which the population is again divided into clusters, and then a random selection of clusters is chosen, and all individuals within the selected clusters are sampled. Unlike stratified, in stratified, each stratum or strata has an equal chance of being represented in a given say for example research, but in cluster sampling we chose certain clusters, and that certain cluster we will survey entire members of it. Okay, next is systematic. From the word systematic, it is intervallic. Say for example, you are surveying a research, or I mean you would like to study the study habits among the every 10th person from from grade 11 students. So from the class record, the 10th, say for example, the 10th name in the class record will be your respondents. The 20th, the 30th, the 50th, and so on and so forth. So that is systematic intervallic. Okay. Next is the non-probability. So I think this is very familiar for you as well because you have you have dealt with this you when you were in grade 11, especially in qualitative research. First is what we call once again, non-probability sampling is a method where the selection of individuals is not random. For probability sampling, we use it for quantitative, but for non-probability sampling, we use it for qualitative research. Here we have what we call first the convenience sampling. So here, this is opportunistic. So participants are selected based on their easy availability to the researcher. So if that respondent is available or convenient for them to respond to your research, of course, they will be your respondents. We also have what we call quota sampling. So from the word quota, the researcher sets a specific number, so quota, specific number for each subgroup, and then uses convenience or judgment to fill those quotas. Therefore, you have this target number of respondents, and you have to make sure that you will be able to reach that sample. Next is purposive sampling, in which this is judgmental. So in this type of sampling, researcher handpicks individual who they believe are most relevant to the research topic. So, of course, if you are dealing with, say, for example, lived experiences of, um, how do you call that? Um, Lived experiences of students who, say, for example, who experienced physical assault. So therefore, in the case of purposive sampling, you will of course interview those students who really experience physical assault. Okay, purposive. Next is research instruments. So we're done with the research respondents. We will move to the research instrument. Of course, these are the tools that we use to collect, measure, and analyze data for specific research problem. And in quantitative research, these tools are meticulously designed to generate numeric data that can be statistically analyzed. They serve as primary means of gathering objective and measurable information from a sample of population. So we use these research instruments, of course, to collect, measure, and analyze data. And to continue, we have here the most frequently used data collection techniques. Actually, combination na ni siya of quantitative and qualitative. First is we have the documentary analysis or in the form of records. Next is we also have interview. This is commonly used in qualitative, such as in the form of conversation, interview schedule, focus group discussion, and we also have types of interview. It can be structured or semi-structured. So I know you have dealt with this in your previous year academic previous years or grade 11 journey. So therefore, I will no longer delve deeper into these. Proceed with observation. Of course, from the word observation, you are watching. Structured, it can be utilized through the use of checklist. So you have this checklist in which you can make use in order to guide you in observing a certain phenomenon. And we also have unstructured, in which you really don't have those checklists or ideas on what to observe. You just have to put everything on a certain sheet of paper. What are your observations? We also have psychological measures, which is biological. And we also have the physiological, psychological test, which is for evaluation purposes. And we also have questionnaires, structured versus unstructured questionnaires. And to continue, let's proceed to some examples of questionnaires, especially in the form of Likert scale. I think most of you use this. It measures the level of agreement with a statement. As you can see here, this is a 5-point Likert scale, where 1 means strongly agree, 2 agree, 3 neutral, 4 disagree, and 5 strongly disagree. So these statements in the statement includes, I like a stock market. So you are to check which among those how do you call that? Which among those indicators do you agree? Do you strongly agree? Do you disagree or strongly disagree? So that's it. Likert scale. Next is we also have semantic differential scale. So you can make use of this as well. This measures attitudes or feelings using a pair of opposite objectives. Here, we still use numbers. For example, numbers 1 to 7. And on the opposite side of it, we have here weak and strong. So two opposite adjectives in order to measure certain behaviors. Bland, flavorful, cheap, expensive, old, and modern. And as you know, these discussions that we have here, it is also anchored in our practical research book. So for more references, you can also browse your books in order to have more information. Next is we're done with the research instruments. Now let's proceed to the validity and reliability of our research instrument. But first, let us define what is validity. So in this case, as we can see, validity refers to the extent to which a research instrument accurately measures what is intended to measure. Say, for example, you're studying about study habits. So, of course, your questionnaire or research instrument should be all about study habits because it measures what it intends to measure. Or in its simpler terms, are we measuring the right thing? Another example here, a questionnaire designed to measure anxiety is valid if it genuinely gauges the individual's anxiety levels and not something else, like stress or nervousness. And without validity, the research findings cannot be considered meaningful. And of course, in research, reliability and validity are two fundamental concepts for evaluating the quality of any research instrument. In short, a reliable instrument is one that provides consistent results, while a valid instrument is one that accurately measures what is intended to measure. And here, we do have different types of validity. To start with, let me first erase everything. First type of validity is the face validity. This is a simple measure whether a research instrument looks valid on its face. It's a subjective assessment by non experts like participants to determine if a test or survey appears to measure what it's supposed to. For example, you are having this survey on the math test that has questions about algebra and geometry. That has a good face validity because it appears to be a math test, right? So therefore, it has face validity. Unlike if, say, for example, you are going to measure math test scores, and then your instrument is all about English. So what's the point? So this is the face validity is already not observed in that given instrument. Face validity. Okay. Next is, let me erase first this one. Next is what we call the content validity, of course. In content validity, as it assesses how well a research instrument covers all aspects of the concepts it's supposed to measure. I have encountered different instruments in which, in their maybe independent or dependent variable, it is only composed of maybe five questions, five items. Is it does it measure content validity? No, because it does not measure all aspects. It just measure maybe some of the aspects. So ideally, your questionnaire or research instrument should cover all aspects of the concepts it's supposed to measure. It's determined by experts who review the instrument to ensure its items are relevant and representative on the entire topic. So the greater or the greater number of items in your research instrument, the better, because it will really measure what is it's supposed to measure. For example, here we have a final exam for history course, which has a good content validity, and it includes questions from every major unit taught in the class. Of course, not just one or two, but it includes every major unit. Okay? So, parehas na sa exam. Say, for example, we are having first quarter examination. Of course, it covers all of the topics in the first quarter. So, each of the topics should have a representative number of items in your exam questions. Okay? Content validity. Next is construct validity, another type of validity, in which it confirms if a test or survey accurately measures the underlying theoretical concept it's designed to assess. It's about ensuring the results make sense within the broader theory. Say, for example, a test for anxiety has a construct validity if its scores correlate with the other anxiety related symptoms, such as increased heart rate. We also have here stress, but do not correlate with unrelated factors like person's height. So, what's the connect of anxiety with the person's height? So, it should be, I say, for example, a research instrument. If it has some indicators, of course, it also measures what it intends to measure. So, that is construct validity. There should be a correlation in between the factors being studied. So this confirms that the instrument is behaving as a theory of anxiety. We move first here. Anxiety would predict. So that is it. Face. We also have the second one. What was it again? We have the content validity, and lastly the construct validity. Now, we also have what we call criterion related validity or equivalence test. This type of validity is an expression of how scores from the test are correlated with an external criterion. So we have here two types, concurrent validity and predictive. So in simpler terms, it measures how well a new test scores correlate with an existing, well-established test that is given at the same time. It's about how accurately a new tool measures a concept in the present. Say, for example, there is a company who develops a new shorter intelligence test. To check its concurrent validity, Of course, they administer both the new test and a longer, widely accepted IQ test to the same group of people. And if the scores of the two tests are strongly correlated, of course, we can conclude that the new test is considered valid for the use in the present. Next, we also have predictive validity. So here, it measures how well a test scores can predict a future outcome. Can that research instrument be used to predict future outcomes? It's about the tool's ability to forecast behavior or performance that will happen later. Say, for example, there is a college who uses the SAT as an admission test. So the SAT has a predictive validity if a student's score on the test taken in high school is a good predictor of their academic performance. Say, for example, GPA in college, which is measured later. I know that you are grade 12 students. Say, for example, you are taking an entrance examination. So does that the score in your entrance examination significantly correlate or predict the ones the GPA in the future? Say for example, if you graduate in college, does the entrance exam score predict your GPA in college, especially when you graduate? So that is it. Concurrent and predictive validity. And these two types of validity are crucial for demonstrating that an instrument's scores are meaningful and useful for their intended purpose. So it's very important to really measure the validity of the research instrument that you were able to adapt with an A or adapt with an O. Okay, or maybe if you are the ones who made that questionnaire, of course, we should ensure that we have these types of validity in our research instruments. And to continue, let's have here another key point, which is the reliability of our instrument. Here, this refers to the consistency of research instrument. It answers the question, if you use this tool repeatedly under the same conditions, will you get the same results? Say, for example, you are using an adapted questionnaire with an A. If that questionnaire will be used again by another researcher, will it get the same result? So that is reliability. A reliable instrument produces stable and consistent scores over time across different raters or among different items within a single test. And for example, a reliable bathroom scale will show the same weight each time you step on it. Say, for example, you're measuring about study habits of grade 11 students today, and then that same research instrument will be used 10 years from now. Will it give you the same result, or maybe not the same, but almost the same, consistent, stable results over time? So that is reliability. And to continue, we have different types of reliability. First is we have the test, retest, or the stability test, in which this assesses the consistency of a research instrument by measuring how similar the results are when the same test is administered to the same group of people at different points of time. Say, for example, in a general mathematics class, you would like to test the knowledge of your students before starting the lesson. So you will have this pre-test or test number one. And after that, after periods of time, you are discussing already the lessons, the concepts, the interventions in general mathematics. And then after a period of time, say for example, after 2 months, you used again another instrument, I mean the same instrument in order to have this post test. And you are to tell whether, oh, is the performance of the students, I mean, does the performance of the students improved after all the lessons, the discussions, and the interventions? So that is test, retest, pre-test, and post-test. Next is we also have internal consistency. So here, it assesses whether all the items within a single test or scale are measuring the same underlying concept. It's about how well the parts of a test hang together. Say, for example, you are again studying about surveying about the study habits of students. Are you sure that all of the items in your research instrument measures the same underlying concept? So that is the thing that you need to make sure in your research instrument. That's why we have this here, internal consistency. We do have types of internal consistency. First is the split half. Please take note of this because this will be administered in your periodical examination. Mugawas yun. Please take note. I hope naminaw pa ka up until here so that you will have the answer to the upcoming periodical examination. So once again, we have this split half. It involves splitting a test into half and serving into two halves and then calculate the correlation between the scores on the two halves. Here we have this formula where, of course, this is our split half internal consistency. R represents here the correlation coefficient computed for split halves. And here, RHB is the estimated reliability of the entire test. And to continue, we have here some examples. Okay. Here, we have sample calculation. What if we have this one? So split half, again, we are looking for the internal, how do you call that? The correlation coefficient or the estimated reliability of the entire test. So using the split half, say for example, we have here this computation in which 0.96 here is given. This is actually our, this one, correlation coefficient of the computed split halves. So here, it's given already, so no need to solve for this. So to continue, again, this is our correlation coefficient, 0.96. You just have to substitute it. And in this case, as you can see, 2 times 0.96, that's 1.92. And 1 plus 0.96, that's 1.96. And if you try to divide this, ooh, the reliability of that certain instrument is very high, almost 1, right? So therefore, that instrument is very reliable, having 0.98 as its reliability score. And to continue, again, please take note of this. This will be used in your, this will be, um, surely, this will be administered in your periodical examination. Okay. Next is another type or another example. Okay. Split half again. We have here a scenario. A 50 item test was split into halves of 25 items each. Of course, half of 50 is 25. The correlation between the scores of the two halves is 0.65. Again, given na po ang correlation. In this case, our correlation between the two halves is 0.65. Just substitute. 2 is given here. 2 times 0.65, that's 1.3. And then add these, we will get 1.65. So therefore, our reliability score for our split half is 0.7879. So in this case, this is acceptable. So we do have what we call the table in interpreting our what we call reliability test. So in this case, I think the table is next here. Just use this. First, before dealing with the table, we will first this one. So this table, a while ago, we got 0.7, so on. So this is a good or acceptable uh, instrument because based on the test, it it uses, or I mean, it is under the scale of 0.70 to 0.80. So it's good. It's a good instrument to use. So once the result is 0.50 and below, oh, that is very alarming because you might need to revise. Revision is needed on that certain research instrument. Okay, so let's go back again to our previous discussion. Again, we do have the split half. We have two more. We have the Cooder Richardson. This is not commonly used, but we will have a glimpse of this. So this is the formula where R sub dt here is the reliability coefficient of the whole test. N is the number of items in the test, and SD sub T is the standard deviation of the total scores. Summation of PQ is tabulating the proportion of persons who answered correctly and the persons who did not answer correctly. So we have here sample problems or sample solution. Here, say for example, we have these 20 items 20 item dichotomous test, right or wrong, was given to 30 students. Again, 20 item given to 30 students, and the proportion of the correct answer for each item P and the incorrect answer Q are already computed. So it's given with the total of summation of the correct and incorrect items is 4.8, and the variance of the total scores is 9.6. So here, we will just immediately substitute. So based on the formula presented a while ago, as you can see, we have here, sorry about that, we have here this legends in which we know that our sample respondents base here is 30. We have 30. That's why we substitute where? Wait, what? Let me first. Sorry about that. So once again, we have here N, which is the number of items in the test. In this case, we have 20 item test. That's why 20 ang nakabutang diriha. Next is the standard deviation of the total scores of the test, and it's given as well. It's 9.6. That's why we have here 9.6. Next is the summation of the proportion of the correct to the incorrect scores. That is 4.8. That is given again. Again, just substitute using the formula. And lastly, 9.6 here below, still the standard deviation of the total scores of the test. So using your calculator, just have to simplify. 20 minus 1, that's 19. 9.6 times 4 minus 4.8, that's 4.8. Then type it in your calculator. Perform calculations, you will get approximately 0.5263. Ooh. So based on the table, let's go back again to the table. 0.53. Is it a good instrument? So based on the table, 0.53 is, belongs here. Therefore, it is fair, but it needs revision. So that is the use of the reliability test using the Cooter-Richardson. Okay? And to continue, let's move forward to the third type of reliability test. And to tell you honestly, this is the most common type of internal consistency reliability test. So here, we were going to use what we call Cronbach alpha. It is used to determine if multiple items on a test or survey are reliably measuring the same underlying concept. Again, this is commonly used. And now we have here A as our Cronbach alpha, of course. K is the number of items in the scale. Again, number of items in the scale. Next is summation of V sub I, which is the sum of the variances in each individual item. Lastly, we have V sub T, which is the variances of the total scale or the sum of all the variances. And to continue, we have here another sample problem. Again, please take note of these formulas formulas because I'm sure that it will come out in your periodical examination. So I do hope na abot mo ani nga part sa akong recording para dili pud useless ang tanan. Okay? Let me first erase everything. Let me have here this sample problem. Okay. Oh, sorry about that. We don't have any sample problem, but the process of getting the answer to this Cronbach alpha is just the same as the Coder Richardson. Okay? In your exam, the number of items will be given. Some of the variances will also be given, as well as the variances of the total score. So don't you worry. What you'll need to do in your examination is just mere substitution. Okay? You substitute it correctly, and at the same time, input it in your calculator accurately. Okay? So that you will have that answer that you want. So once again, let me erase this one. Those are the types of internal consistency. Let's review. First is we have the split halves. This is the formula. We also have Coder-Richardson test. We also have this Cronbach alpha, which is the commonly used test for internal consistency. And I guess upon conducting pilot testing in a different school or different place, you will be using this instrument. Okay, I mean, you will be using this uh, tool in order to measure the reliability of your instruments. Does your instrument measure the same underlying concept? So you will use this Cronbach alpha. Okay? Again, I will just emphasize, once again, we will use Cronbach alpha in determining the reliability of our questionnaire aside from conducting validity, test of validity. Okay? Aside from test of validity, we also use reliability test using Cronbach alpha. And to continue, again, this is a tool in order or a table in order to measure reliability of a certain instrument. So this is the range of values, and here is our interpretation. Is it excellent? Is it very good? Good, fair revision, or poor? If it's 0.70 above, of course, that's a great indication that your instrument is good. Okay? It is acceptable. But once it is below it, such as 0.50 and below, sorry, but your questionnaire needs revision, and there's a greater chance that you might conduct again another validity and reliability test, or you will pilot again another set of respondents. Okay? So that is the indication of the validity and reliability of research instruments. And I guess that is all for now. I will just have a continuation of this, which will be all about the statistical treatment of data on my next recording. Thank you for listening, and I do hope you've learned something for today's discussion. Once again, this has been Ma'am Anna saying God bless, and I do hope you really listened and understood the discussion for you to be able to answer the upcoming periodical examination problem solving part. Okay?